And now let me invite Siddharth Shetty. He's also a fellow of iSpirit. Again, I talked about the mission of iSpirit. Siddharth had his own startup at the age of 17, comes from a business family. Into mathematics and cryptology, actually, Saurabh was saying that despite not having PhD, he knows about cryptology as much as Saurabh does, at least half in jest. So Siddharth is involved in multiple initiatives which build upon India Stack, which, as we know, comprises of UPI, eKYC, Aadhaar, and so on. Also involved on the technology which goes in by RBI for public credit registry. What he's going to talk about is something that India has launched as a policy for UAVs, which are commonly called drones. So managing this challenge, addressing this challenge of managing millions of drones which possibly could be in Indian airspace. So that is something that he's going to talk about. Thanks.
Thanks, Hemant. Before I start, I want to address a question that got asked earlier with respect to access to data. So India is actually working on something called the Data Empowerment and Protection Architecture. Basically, it's a rollout of giving Indians control of their data through consent. So if you go to indiastack.org/DEPA, you'll be able to find that out. It's already rolling out for all financial data as well as telecom. So you should definitely check that out. We've been looking at health data as well, and we have a pilot running, but there are a whole bunch of other issues because of the unstructured nature of that ecosystem. So as iSpirit, being a nonprofit organization, we've been working on a number of public platforms, large-scale public platforms. Aadhaar has 1 billion plus Indians on board, through which people can digitally authenticate. UPI, Beam UPI is a real-time payments platform, now the world's fastest growing payments platform. Last month it did about 600 million transactions, about 1 trillion rupees went through it. Taking a lot of those principles and learnings from designing and architecting these platforms, we thought, can we apply it to UAVs? So the government of India, and actually governments across the world, have been, drones have been a fairly mature technology over the past 30 to 40 years, primarily being used on the military side of things. Governments across the world are now trying to ask the question, how do we safely integrate these into civilian airspace so that you can use it for a number of use cases? One of the presenters earlier today spoke about wildlife conservations and using drones for that. You have using drones for logistics delivery. In countries like Africa, drones are actually used to kind of leapfrog the physical boundaries and deliver organs and blood and stuff like that. And therefore, about a year back, we started working with the Indian government and civil aviation authorities, primarily with the objective that if we need to safely support 1 million drones, primarily we design for scale as well as diversity, what would be those fundamental building blocks that need to be put in place? And that's when the government created something called Digital Sky. The first layer we realized was actually about trust. It's very important to know who are the trusted entities in the particular ecosystem. So in the case of drones, it would be the operator, the manufacturer, the pilot, and the drone itself. And so through Digital Sky, each of these entities can electronically register. So India has come up with a standard through which the drone itself gets electronically registered. So if any of you going forward buy a legally compliant drone, when you actually activate it, it would fire off an API call to DGCA to register itself. The second layer of Digital Sky concerns permissioning. So let's say you want to fly in a particular area or in a particular airspace at some point in time, you need to ask for permission. Now what we do know is, given that enforcement in India is extremely poor, what we thought is, can we move to a proactive form of enforcement and actually bake that into the firmware of a drone? So India came up with a standard which no one else in the world has, called NPNT, no permission, no takeoff. So essentially what we said is, earlier on you'd procedurally enforce this, telling a user, go to a portal, apply for permission. If you're caught flying without that permission or permission request, we will penalize you. But like I said, given that we are poor with enforcement, we thought, what if there could be an application? People apply for permission saying, let's say I want to fly around this area at this point in time. If approved, a machine-readable, digitally signed file is generated by the system, and that feeds back into the drone. And the drone's firmware then checks the lat-long details, the date time details, the integrity because it's been digitally signed, and a bunch of other metadata. And if all of them check out right, it would actually activate and you can arm the drone. So as we speak, December 1st last year, so December 1st, 2018, India actually rolled out this as part of the policy. So going forward, any drone sold in India would be NP/NT compliant, and a bunch of Indian as well as international drone manufacturers are currently underway on the implementation of that. So if you don't have a permission, you can buy a drone, but it just will not arm itself, no matter what you do. And then basically the way it would work is India segregating airspace right now in a fairly rule-based manner of red, amber, green zones. So green zones are where you'll get immediate approvals and your digitally signed file would be generated right away. Think of this as low-risk areas. Amber zones are, think of them as controlled airspace, where when you apply for permission, an agency like air traffic control would actually go ahead and have to review that request, and they may approve or deny it. And if approved, you get that same file which feeds back into your drone. And then red areas, think of them as around airports or other highly sensitive zones. And the third layer of digital sky is essentially tracking, which we'd get to a few years down the line, primarily because a lot of the technologies are either extremely expensive, nascent, not commoditized yet. And so for the time being, the way things work is once your drone flies, a digitally signed flight log is generated that's sent back to the system. And as the technologies mature and get commoditized and more drone manufacturers incorporate tracking abilities, we'd then be able to move towards much more real-time forms of telemetry. So this is, as we speak, the Indian government's now building out the digital infrastructure, investing millions of dollars in building out the digital infrastructure for this. We're actually the third country in the world that's doing it and deciding to go ahead and build out our own. You must understand the context, which is till now, at least in Indian civil aviation, right from the regulations to the technology that runs these systems has actually been imported. So India is actually taking a very frontier role in not only coming up with drone regulations, putting it out there, allowing drones to fly, but also saying we'll go ahead and build out the tech from scratch. And also with things like NP/NT, which we're now seeing other civil aviation regulators in other parts of the world wanting to adopt. Typically, it's the other way around. At a broad level, what you need to understand is, on one hand, India's this infrastructure would integrate manned aviation systems. This is very important for people thinking about use cases, especially logistics. The economics of logistics are such that if any of these large companies need to enable deliveries over drones, the warehouse needs to be situated near an airport. And so unless our flight information systems for drones do not integrate with manned aircraft data, we'll not be able to give drones authorizations to fly near manned aircrafts. And so that's one part of the puzzle. The second is it would integrate with a number of internal systems which we have for weather data and other forms of airspace constraints and things like that. And also we're building out a bunch of systems of our own, like a telemetry engine, GIS engine, and a bunch of dashboards that and command and controls that our security agencies can use. We're abstracting that into a neat layer, what we call the Unified Flight Information Interface. This would expose little neat RESTful APIs to the ecosystem. And what we've allowed for is an ecosystem of what are called digital sky service providers. So today, if you go to digitalsky.dgca.gov.in, you will see the first instantiation of a DSP through which you can register, apply for permission, etc. However, over a period of time, a large number of companies, private and public, would come into play that role. And basically, the shift that has happened is earlier the government would build out one portal and hammer everyone to use that. Instead, the government's building out a core API platform and allowing market participants to build the front-end experiences on top. Again, important because we have 1 billion plus people, which is extremely heterogeneous. And the way it would work is a bunch of APIs would share information about airspace, so constraints and directives about the airspace. Then operators and the drones itself can send in a bunch of requests and permissions saying that we want to fly in this particular area at this point in time. And then let's say if you have, especially in high density airspace, a bunch of back and forths in terms of operations and deviations. So if you have 10 drones flying in an area, an emergency drone needs to pass, in real time you have to now issue new sets of operations asking those 10 to change and deviate their paths to allow the crossing of this emergency drone. So development of this has already started. And I just wanted to share a bunch of specific areas where, as we've been thinking through the system, we'd like a lot more help. The first part, and it goes back to what I mentioned earlier about trust, is how do you identify a drone in a non-reputable manner? So what biometrics are to a human being, what is that to a drone or a piece of hardware? We've come up with a minimal set of standards already, but a lot of work can go into actually thinking through. You've got some amount of literature in physically unclonable functions and stuff like that. So can we leverage some of those to improve the trust factor of these civilian drones? And once you've improved the trust, you can actually allow it to fly in far more sensitive areas. Today an area is red because the security agencies don't trust whether it's a good actor or not. But if we can improve the trust factor on the drone itself, tomorrow that actually increase the airspace in terms of the green zones. The second question is, how do we ensure integrity of code that runs on the flight controller? Like I mentioned, because India has come up with a standard called no permission, no takeoff, all drone manufacturers are now implementing a bunch of code as per that specification that's running on their firmware or flight controller. A lot of methods, for example, work that's happening on formal specifications and things like that could actually be leveraged to improve and ensure integrity of code. And that way we know indeed no permission, no takeoffs being enforced instead of the current method where we're doing a bunch of functional and other types of certification. The third is, as we talk about 1 million drones flying in the airspace, and that's where a lot of work, especially in the data science, would be helpful because you can actually start generating predictions, is how do we completely automate this? Because the current air traffic control systems that we had, which are human-driven, would not be able to manage. So one is, how do we completely automate it? At the same time, how do we, in an automated manner, handle conflict resolution, especially when you have multiple drones flying in a low density, a high density area? We found a lot of need for sharing of flight log data with different parties. So for example, insurers today are unable to actually provide insurance policies to drone operators because they lack flight log data for their actuaries to work on. Can we enable a privacy preserving way for them to do that? Another form of data sharing is, today if a civilian applies to fly in a particular zone, which has been designated by the defense as say an amber zone, the process that works is that request goes to a nodal agency. That nodal agency has data about defense flight paths, and then a human being actually compares the two and decides whether I should approve or not. Using some of the advances in, say, secure multi-party computation, etc., we could enable both of this to happen where the civilian flight operators share their data, the defense authorities share their data in completely privacy-preserving manners, and then the output is yes or no, whether you can fly in that region or not. And lastly, a lot of drone flights are going to take place within, think of Shadi photography within indoor areas. Say even at IISc, a lot of tree cover, so you start lacking GPS connectivity. So as we think and India builds out this traffic management system, how do we handle environments where there's a lack of GPS connectivity? So this is kind of the broad set of problems, and if anyone's really interested in working on this, then happy to take it from there. And any questions?
No permission, no takeoff, and you're talking about integrity of the code.
Yeah.
I mean, so this is like a very hard problem in terms of we have seen it in the DVD copywriting and many other areas as well. So the player that plays the DVD, it's supposed to check the signature and only then play, kind of. That's also a hardware, similar kind of issue.
Yeah.
So a lot of the solutions that came up in that space, I mean, again, as far as I know, it's not just the software integrity code check. There is a lot of hardware tampering. I mean, you could, easily bypass. You have access to the OS. What is there? I mean, there are many things you can do which will bypass all these modules and do whatever it is that you want. So the solution, and typically the solutions there, if you really want, is mainly tamper-proof hardware and things like that, which turn out to be super expensive in terms of. So what is the direction? I mean, are you really looking at tamper-proof hardware?
Yeah, so we are. In fact, the standard India has put out, and you should, to find that out, if you Google for DGCA, if you go to digitalsky.dgca.gov.in and look at the bottom footer, you'll see something called the guidance manual. Chapter 6 defines this. We're thinking of it at 2 layers, and really the implication on the hardware side is less the technology, more the supply chain implications for manufacturers. It's easier to write code, it's tougher to bake in new hardware requirements, much longer supply chain cycles. But the standard India's come up with right now is at 2 levels. Level 0 is a pure software-based implementation. Of course, you will not get the same hardware guarantees of trust that you do in, say, a trusted environment. And that's why we've already defined a level 1. And few of the manufacturers are already working on a level 1 implementation, which is within these trusted execution environments. There is some research work I've read where some people are able to get the same hardware guarantees using just software, and I'm interested in, if anyone's looking at that area, that would be something much more practical for manufacturers to implement. But as of now, yes, a set of them are working on hardware implementations of this. And the way it's enforceable is because you now have a digital permissioning system. You can say, for this area, I would only allow L1 operators, but this area, because it's less sensitive, I'll allow L0 as well. And that, therefore, it incentivizes people to also move up the chain.
Another very minor.
Sure, yeah.
Curiosity is when you apply for this permission, do you have to specify, I was just curious that you have to specify the entire plan of your path, including the duration. I mean, I was wondering, let's say you got permission for this duration.
Yeah.
Whatever delays, you started half an hour into it, and it is flying, and it's somewhere there, and the half an hour ended.
Yeah.
It just dropped.
No, so there are, again, about 2-3 ways to look at this. One is, right now you apply for not a flight path, but a flight envelope, which is, let's say you want to fly in a particular area, you'll apply for that envelope itself and not your exact path. So that gives you sufficient amount of buffer to maneuver around. And if you cross that path, depending on the area itself, there'd either be a form of soft geofencing or hard. Now, soft is basically if you cross either the lat-long path which you applied for permission or the date time as well, the time range you applied for permission, then that would be logged in your flight logs as a breach. And later on, since the flight logs are generated on the drone itself and signed by the drone, you as an operator can't tamper with it, and so you'll have to file an incident report explaining yourself. In certain sensitive areas, it would be a hard geofence, and so if you cross that boundary, it would activate a return to home, or whatever's the safest alternative. In some cases, returning back to home won't be as safe as, say, safely landing within that area. And so that's left to manufacturers to define depending on the environment conditions that exist. But right now, it's broad envelopes, both time and location. We want to move towards much more granular flight paths, especially as the density of flights increases. But then by then, also the telemetry technology, the transponding technology would mature to facilitate that at scale.
Are there policies for public security and safety?
Yeah, so the first version of India's drone policy, which went live on 1st December 2018, allows for use cases like public safety and security, both by either a civilian organization or government and police organizations as well. And so a lot of state governments and state police are in fact now prepping themselves to participate for that, because they can now ask for permission and fly for surveillance and other such purposes.
Okay. Thank you, Siddharth.
Thank you so much. Yeah.